Okay, welcome back, YouTube. I've been promising this for a while. You want to see some heavy machining on a relatively small machine. I was waiting for the sort of perfect moment where I was on top of the job and we could go through it at a bit of a slower pace. But it does look like that moment isn't going to come. These at the moment, billets seem to be coming through the door quicker than they're going out. So we're going to sort of join halfway through a job here, and we'll have a little look at what we're going to do. For those of you who are new to the channel, because I know there's a few new people, new subscribers, which is great. You know, that's brilliant. I'm going to talk a little bit about the machine first. It's a 1957, I believe, Woodhouse and Mitchell machine. It's really, I mean, really, it's only classed as a small lathe, but it's relatively, high spec for a small machine. So it's got a big 4 horsepower old Siemens motor on the back there. With a triple belt drive going up to a geared head. It's got a 16-speed gearbox. It runs relatively slow in today's terms. I think it tops out at about let's have a look. Yeah, it tops out at just under 1200 RPMs. But I mean, this, you know, it's not designed to be running real fast parts. So we just got the motors running at the moment to warm things up before we start cutting, because it is winter here. And for those of you who've been watching A-Bomb's videos of his trips around Florida, let me just give you a quick peek at the temperature in here at the moment, and it is, yeah, it's about 8 degrees or 45 about 48 Fahrenheit for all of those who are watching in America, which is virtually tropical for Wales at this time of year. Okay, so like I said, we got the machine warming up at the moment. We've machined the one end, so this diameter is to size. Our shoulder is at the moment, it's about a mil over, or about 40 thou over. And what we've done is we've turned it around in a check, and I've indicated in 2 places. I've indicated here, and then I've come right out here and I've indicated, and then we've drilled a new center, and now we're going to take this down now to our finished sizes, and then we'll remachine this size, which is about 3 mil up at the moment, and we'll machine it square, so that everything's running true. But just so you know, this diameter here basically just locates in a bore, and it's probably, I think, probably 1/4 millimeter tolerance. It's quite a big tolerance around that, so we're not too worried if there is a little bit of throw in that. Now the machine itself will only take 8.5 inches over the carriage, and this is currently 10 inches, so we can machine about 3 inches at a time until we get down to 8.5 inches. Then we can clear the carriage and we can move up a bit. So basically we'll take the whole billet down as far as about here, to 8.5 inches. Then we'll start taking out diameters. At the moment we are running pretty slow, just to get through this nasty skin. I don't know if you can see that. There's a nasty spiral groove in there, and there's And there's some yeah, see, we got a nice little valley in there, and a couple of mountains, and God knows what. It's not a particularly good quality billet. There's another one there as well. So we're taking it slow, and we're taking, at the moment, we are taking 80 thousandths per pass, and we are we're at about 9,000 per rev. Okay, so we'll get it turning. Everything seems to have warmed up quite nicely now. Let's get him into gear. There we go, and I'll get you set up on the stand, and we'll make some chips. Right, so you're nicely set up now. If if lots and lots of turning bores you, it's probably time to visit another channel, because this is going to take some time. All right, let's go. So we're using these, sorry, I should have covered it, but we got this new insert holder which uses the opposite corners of a CNMG insert, and these CNMGs have got the TK chip breaker. I'll show you on that. Those of you who follow me on Instagram would have seen quite a bit about these, because these are my my new insert of choice for this sort of work. See, they got a real high positive chip breaker on them, and they do very well again under the skin of these. Okay, so we'll pick up where we left off yesterday, and that's about it really. Sit back and enjoy. Any minute now. Go. Okay, so we're down past the nasties now, and we've upped the speed now. We're now running at 75 RPM. We got the same feed rate, and we're still doing 80,000 steps per cut. Ideally, we could do it running a little bit faster. Well, you know, the inserts will take it a little bit faster, but obviously, since we still got a pile of out of balance, lumpy material in the middle, we don't really want to, you know, put too much pressure on the bearings of a 70-year-old machine with that jumping round in between the tailstock and whatnot. Okay, so some of you were probably wondering why it was I didn't take a facing cut and that I put up with all that intermittent cutting at the start of the cut. Well, the reason is when I started, if you look down here, I had absolutely no clearance, or very, very little clearance between the carriage and the actual job. And what happens is when I take a facing cut, my chips are going to go this way, and what can happen is they can pack up underneath there, and that makes this billet want to ride over them and jump out, which is obviously not good, because, you know, considering the amount of you know, sort of energy that this has got when it's turning, it's going to snap this tailstock in two. So that's why I've taken a pile of material off, so I've got plenty of clearance under here for chips. Now I can take a facing cut, and I've switched the tool out to a normal CNMG holder, same inserts, exactly the same inserts. Obviously now we're using the other corner. We're going to take a facing cut now as deep as we can go, without obviously hitting the center, and then we can carry on cutting away. What we'll do is we're going to up the feed rate now, and we'll take a nice facing cut across there. Okay, so let's see how this does. Okay, so nothing too dramatic, just to start. But you can see what I mean down here about the chips. Very easy for them to pack up down there, and for this to wanna drive right over them. So that's why we've taken the top off first. We got varying thicknesses there because the end's out the true. That's why we're having them nasty little chips coming off every now and then. In fact, I tell you, I might up the feed rate a little bit more. Let's see how she likes this. Okay. So hopefully now you can see just below the job there the issue that we would have had if we didn't have any clearance there. I'd probably be trying to pick this up off the floor now and you know, nursing a very broken tailstock. If you're considering doing sort of heavy machining on sort of a machine that's probably not quite big enough, or you're right on the limit of a machine's capacity, things like, you know, having clearance for the chips to disappear and things like that are worth considering before you sort of find out the hard way. Another thing is, you know, obviously, you know, we need to stop the spindle because we need to measure it at some point. Now this machine, if I come over here, this machine, this is the clutch, and all the way back that way applies the brake. Now, you know, this started off at about 160 kilos, and it's probably not far off that now. I would imagine around the 140, 145 kilo mark. So it gathers quite a bit of momentum when it's spinning, and purely just for saving, you know, my machine. You know, if I need to stop the spindle now, I'm just going to take the clutch out, you know, and let it slow down, you know, rather than, you know, just slamming the brake on. You know, once it's slowed down a bit, you know, then I can apply the brake and it's stopped. But obviously what I don't want to be doing is stopping this sort of mid-flight, and also with starting as well. You know, I don't want to be jamming this into gear and you know, going too mad with it. Now we've put our other holder back in now. I'm just going to touch back off. We're nowhere near needing to measure anything at the moment. We got about off the top, there we go, off the top of my head we got about 10 millimeters or 3/8 to come off the length of it, and you know, a good 6 inches to come off a diameter. So Now we got our size down a bit. We're still at 75 RPM, but we're gonna take hang on, see, talking on you, I almost forgot something. I didn't lower my feed rate. Now again, this machine's got a few safeguards on there. There's a clutch there on the actual feed shaft, and obviously there's a clutch in the gearbox that'll both cut in if it takes too heavy a cut, but I don't want to wear either of them out, so we'll make sure we're back where we need to be, and we'll take 0 up, say, okay, so we're going to take 90 thou this time, see if we can get some more of this material off. Okay, so at this feed rate and this depth of cut and this speed, we're a bit more closer, or a bit closer to what the insert wants to do. If you look, our chips are again a little bit more golden. And we're doing some work. Right, I'll bring you back in a minute. So I thought, while that's cutting, perhaps you'd like to come on a little machine shop tour. So since we got about 4.5 minutes for that to finish the cut, over here we got tapping oils, and there's the 3-phase distribution board there, and some measuring equipment, sort of, you know, the regular stuff that I use, and there's a mirror just in case I get something in my eye. Nice and close. Out there through the window you can see that's fabrication and sheet metal work, and there's a storage rack up by there and whatnot. Then we got my Oxford women's rugby calendar, and you know, as you can probably tell, I'm not really a very big rugby fan. Okay, so this way, I'm not going to show you the floor because it's full of chips at the moment. I should be ashamed of myself. So over here we got emery cloth there, some number plates, tool holders, files, you know, a few old drills, chuck drills, mandrels, boring bars, general cleany stuff and wipey stuff. We got a little dial test indicator there. I'm sitting up on the thing here, my glasses, my spare glasses, because I got my ones on, my drawer in, very important. Really, I probably need to sort this top drawer out, but that's where everything tends to get dumped. So we got stones and deburrers and old indicators. Then we got feeler gauges, screw pitch gauges, thread gauges, drill gauges, a load of high spiel ground bits for various different things, inserts, lots of inserts. Then we got vernier calipers, bore gauges, another test indicator there, another style of bore gauge there. There's an OD gauge there. Right, we're gonna have to go back out to the machine now. Oh no, we're alright for a minute, we're alright. Then we got Okay, micrometers up to 6" in here, and then we got the bigger ones and test bars. There's also a depth mic in there as well. Oh, we're nearly there, hang on. Normally I'm watching YouTube now, so that's one of the only things that I'm not so thrilled about is with this holder and using that corner of the insert is that you can't turn that to a square shoulder, but I mean it does mean that you get twice the use out of your insert, so I think I'll live with it. Okay, here we go. I'll put that on. Okay, right, where were we? Okay, so we did micrometers, then we got adjustable parallels, more parallels, a wiggler, bore gauges. There's a square, a master square in there, a set of gauge blocks, V blocks, homemade 1, 2, 3 block. Then we got what have we got down here? Okay, this is all mill tooling, 5C collets, shell mills, drill chucks, whatnot. And then we got this is the lathe tooling, boring bars, nice little Albrecht chuck there on a number 1 Morse taper. Big boring bars, lots of different left-hand cutters, right-hand cutters, you know, all sorts of different stuff in there. Then we got a pile of boxes and basically stuff in there. Hang on, let me move out of the way a minute. Okay, over here we got this is mainly mill stuff. So we got drills, lots of drills, counter bores, more drawings. Oh, there we go. The engineer's black book, that stays there. The machine taps there, spanners, Bridgeport spanners, countersinks, rotor broach bits. What have we got over here? Allen keys, trammel bar points. Then we got tap handles, dies, die handles, measuring tools, and a length of drill rod. I don't know why. Okay, so we got them. Scale rule, I talked about them in my pattern development. If you haven't got one and you do really any sort of sheet metal fabrication or anything like that, you need to get one and you need to learn how to use one. End mills, all sorts of different flavors, little ones, inserts, slitting saws, more insert end mills, shell mills, dovetail cutters, etc, etc. Then we got taps, lots of taps, all sorts of BSP taps, metric fine, BSW, then we got drills, big drills. Yeah, there we go. That's about as close to A-bomb size drills I get. That's a 35mm drill. And last, before we got to go and put the next cut on, is reams. Lots of them. There we go. The quickest machine shop tour in history. Okay, so what we'll do is we'll put this next cut on now, and then we'll go down and have a look down by the surface grinder and whatnot. We're nearly okay, I think. Yeah, we're at diameter now where we can clear the carriage. So what we'll do now is we'll bring it out. Hang on, let me just set you up and we'll take some more of this skin off. Okay, so we've slowed it down again now, and we've lowered the feed rate because this skin on this billet is really hard going on the inserts, and it's hard going on a machine, and you know, we don't want to kill it just for one job. So we're back down to 35 RPM. Dropped our feed rate again. We're gonna take another 3 or so inches now. Again, the other thing I gotta be really careful of is that no chips are gonna pack underneath there. Like I said, we don't want that jumping over at us. We're going to be quite gentle here. We're probably only going to dial in about 50 thou off the highest point of this, and hopefully that'll get us underneath it, but we'll see how it goes now. Okay, we dialed in. We dialed in 70,000, so that should get us underneath it. Ideally, we want to take it in one go, and so let's see how it goes. Okay, we'll just check, see if that's cleaning up. Another thing you need to consider, that I've never really had to consider in the past when you're pricing a job like this, is coolant. I used to change the coolant in this probably, I don't know, every 6 months maybe, you know, to stop it getting the skin on it and whatnot. But believe it or not, once we get down to small diameters now, and we're up in the RPMs, and we're up in the feed rates and whatnot, I was actually evaporating about 4 or 5 litres, you know, in a day. You know, it's a 60-litre tank on this machine, so I was actually, you know, 5 litres a day was actually disappearing. You know, so I was refilling the tank once a week, so it's worth considering. You know, You know, you're talking probably a litre, maybe a litre and a half of suds oil and 60 litres of water. You know, it's worth considering. Now, although it doesn't look like it's particularly hard work, let me show you the DRO and you'll see what's happening as it comes round. Yeah, so it's actually, you know, it's struggling to get over these lumps and bumps. It really doesn't like this sort of semi-interrupted cutting. Okay, so since we got a few minutes, shall we continue around the mini shop tour? So we've seen these two boxes. We didn't see what's down the bottom, but there's not a great deal interesting down there. So we got grinders here. Down here we got big mics. So we got 150 to 175 and then 225 to 250 there. There's also some linear mics down in the bottom of the cupboard over there. Here we have one of my mini pallets and the clamping accessories and whatnot. Here from is a set of parallel clamps there as well, and spare nuts and bolts. Then we got mini steady that I use for the spin indexer because I haven't got a tailstock for it. Then down there we got slide-away oil, hydraulic oil. There's a Z-axis power feed there that's going on the mill as soon as I got time to shut it down. Then we got the coolant pump then for surface grinder, another grinder there. Then we got the Jones & Shipman surface grinder. It's a little bit difficult at the moment because obviously we are full of billets everywhere. Then over here we've got the compressor there underneath there. Whole pile of mill stuff here, indexers, collet holders, collets. It's a little bit of a mess over here. We got the big face mill there. There's a surface plate in the box there, well, covered by the box. And we got the bridge board. There we go. So that's you've seen that's been in quite a few videos. The mist coolant system there for the bridge port, that's all plumbed into the air lines. There's an air line there, and there's there's the welding sets and whatnot, plasma cutter, a pile of boxes that probably shouldn't be there. We got the little CNC engraver there. I know there's cups everywhere. My wife goes on about this all the time. My bench is full of rubbish at the moment because we've just finished another job and that's all got to go. and then we're back to my rugby calendar, purely for the love of the sport. And here we go. Oh, right, I should show you this as well. If we look up here, we have the hoist. Now that was an eBay purchase. It was very, very cheap. It was less than £70. And well, I mean, basically this job just wouldn't have been possible without some sort of lifting gear above the machine. This will, if I can just show you, this will move back and forwards along the track there, which means I can pick stuff up. And I'm just looking to see if we still got, yeah, we're all right. And put it on and off the machine. Right, well, I'm gonna leave you to it for a minute now, and then I'll bring you back when we're ready to do the next couple of diameters. Now, so why don't we try and see how it goes at this recommended depth. Right, so there we are, we're zeroed up, and we're going to go 100 and, there we go, we'll go for 120,000. Now that's with this machine, that's reading the actual travel. That's not off the diameter. That's the actual travel of the cross slide. So there we go. That's how deep we are on it. Let's have a look. See how she gets. Okay, we're picking up on it. Okay, so she's not really liking that. So what I'm gonna do, I don't know. Okay, what I'm gonna do is I'm gonna drop that. I'm gonna drop that down to 100,000. And see how she likes that. Oh, there we go. Yeah, she's alright with that. She's okay with that. Again, we could probably do it going a little bit quicker, because you know, that's probably a little bit slow for that depth of cut, but she's doing okay, I think. Since we're down past the lumpy bits, what I'll do is I'll speed him up a bit now, and we'll see how she takes it at that. So there we go. That's still 100,000 depth cut. It's double the RPMs. We're now up at 75 RPM, and I suppose it just goes to show that if you're getting vibration, or you're getting rubbing, or you're getting something like that, slowing things down and reducing feed rates isn't always the way to go. Sometimes you need to sort of you need to stop babying the tools, and you need to get stuck in and make the insert do what it's meant to do. So there we go. I think I might have rubbed my oily finger on the lens a minute. Let me just clean it off. There we go, that's better. Yeah, like I said, you know, if you're having problems with rubbing, or you're having problems with you know, your chip formation or anything like that. It's sometimes you just need to push it harder, and you just need to speed things up and increase feed rates and whatnot, especially with carbide tooling. You know, it's meant to be worked hard. It's meant to take a bit of a pounding. If it was high speed, it'd be different, but okay, so since we got our RPMs in a better range now, why don't we try it a little bit deeper? So that's 110 thousandths on the dial, so that's 220 thousandths off the diameter, or about 5.5 mil. For the very small percentage of UK viewers that I have. So there we go. Like I was saying, if you're having problems, sometimes you just got to up it a bit, you know, push the inserts a little bit harder, get them doing what they're meant to do. We'll take this pass and then we'll try them at 120,000 step. Okay, let's wind them back. There we go. Oop. Okay, so there's our 110 and 120. Let's see how she likes this. Oop, sorry. So there we go. She looks reasonably happy taking that. That's just about the maximum depth of cut with this insert. There's a little bit of vibration, but I can live with it at these sort of material removal rates. So just for fun, it's been as a year, I thought perhaps we'll try 125 thousandths, just to see how she copes. So that's a 1/4 inch off the diameter. The numbers don't sound particularly big, but what you've got to remember is this. This is only a 4 horsepower machine. It's and it's 70 years old. So we're taking reasonable size cuts here. The other thing that we got to remember is that we're stuck out quite a long way with our tailstock there, because obviously we need to be able to get you know, sort of down the length of it without messing about too much. If I close the, once I'm down at this end, if I then close this tailstock up a bit, you know, I'm going to be that much more rigid and we can take a bit more. But they're not bad numbers for a 4 horsepower machine. Right, okay, so we're on, there we go, 125 thousandths, or 3.2 millimeters. There we go. She's certainly taken it. There's a little bit of vibration here. When I don't know if you can hear this sort of like a drone, a very deep drone in the background. But you know, she's happy. The motor's not straining. You know, this clutch on the feed shaft here, that's really, I would imagine it's probably a little bit worn, considering it's 70 years old, and that's sort, you know, that gives up but you know, the slightest bit of resistance, so we're looking pretty good. One of the issues I got with this insert is if you look at the back, it's got very little sort of rake on there, and what happens is when a chip comes up over the back there, one will jam down in there and puts a pile of pressure on the machine. You can see this one, it just wants to turn and slip down there, and it's you know, I've had small chips on finishing cuts go down there, and see, one's gone in there now, and you know, it just causes a massive score around the job. You know, you can polish it out, but it's just a pain in the arse, like. Just to make you aware, these depth of cut are only possible because of this, the geometry of the insert. This is very little to do with the actual horsepower of the machine or anything like that. If I was to put a normal CNMG in there now, because it's obviously this is a negative geometry tool holder. If I was to put a normal CNMG in there now, I wouldn't be able to get, in fact, I could probably just about take a finishing cut, maybe 20 or 30 thousandths before I start to get rubbing, purely because this machine just hasn't got enough power to make negative inserts work at these sort of depths of cut. So, you know, don't use an insert because you know, your favorite YouTube person uses that sort of insert. You know, use it because that's the one that you know, works best for your machine. Try some. You know, there's I buy all my inserts from a company called Cutwell, and if you're in the UK, they sell in some cases they'll sell you a single insert. You know, so if you want to try some out and see what works best for your machine, for the material, for the sort of feed rates you're looking for, the sort of depths of cut you're looking for, you know, try lots of them. Try different geometries, try different holders, try high speed, you know, just try stuff, you know, because chances are that you know, there's something more efficient or, you know, or better out there for what it is that you're trying to do, and more importantly, what you're trying to do it with. Especially if you've got the sort of your sort of Colchester students and stuff like that, where you've got perhaps 2 or 3 horsepower, yet you wanna remove some material, then try them out, give them a go. Okay, so we're back over at the toolbox, and I just thought I'd show you. These inserts that I'm using today. These ones were Kyocera, and there's the information there, and the important bit here is this TK chip breaker. Okay, these are the same inserts. They're just no, sorry, they're not. Here's a DNMG with a positive geometry. There we go. See, that's for an upside down boring bar that I got, or a boring bar that I run upside down. I tried these. These got a little bit, if you can see. These got a little bit. That's a slightly different chip breaker, but I didn't have any luck at all with them. These are the ones that I used originally. Now I've used these on all sorts of stuff, with no problems, but at deep depths of cut with the power that I got, absolutely no chance. Yeah, so bearing in mind. This is another one that worked very well. This is a DNMG, but I got a positive geometry or neutral geometry holder for these, and these seem to work very well. And they are that's a PF chip breaker on them. Yeah, like I said, learn about your inserts, try them out, and see what works for you. Because I'll guarantee that the ones you're using probably aren't the best ones for your machine. And the only thing I suppose is that it varies between materials, between what you're trying to do, the sort of where you're finishing, where you're roughing. So it does get expensive when you need a whole pile of different inserts for different things. And I am really found a sort of chips building up on it. I am really found a sort of dual insert that covers everything and allows you to face, allows you to turn up to a shoulder, allows you to, it's difficult, but nobody said it was cheap today. When I said about not using an insert, a particular type of insert, because because your favorite YouTube machinist uses one, what I meant was, if you see Adam Booth or Tom Lipton, taking 200,000, 250,000 stabs a cut with a say a WNMG, they can do it because they got the horsepower to do it. What I didn't mean was don't listen to what their advice and what they got to say, because the only reason that I'm now using these high positive inserts is because of a post a while ago that Tom Lipton made about free cutting of sort of awkward materials, and that was the only reason that I even started looking into different sort of types of chip breaker and how they were going to work for what I wanted to do. So take note and listen, and there's far too much information out there to take in, or even or even learn over the years. There's just so much of it out there. We're learning every day, you know. So yeah, you know, take notice of what they're saying. But just because an insert works on their, you know, 10 horsepower machine, you know, it doesn't mean for one single second that that your Myford or your closing or your South Bend is going to have the same results from it, you know. But like I said, you know, listen and pay attention, especially to the boring bits when people are talking. You know, it's nice watching machining and it's nice watching chips coming off and all that, but you know, the real sort of diamonds are in what's being said and whatnot. So you know, just a bit of advice there. Right, back to this job. This is our last cut now before we can shift up again. We can clear the carriage now. Because I've been talking, I think we probably could have cleared it about 2 cuts ago, but there we go, it's got to come off anyway. So we're probably looking at maybe another maybe 2 moves. I might be able to stick the compound out a bit and get this in one. We'll have a look now. Okay, so earlier when I mentioned about the vibration and the chips coming back was like that vibration is basically from from the insert rubbing, because it's not being fed hard enough, or it's not being, you know, it's not traveling fast enough, or it's not seeing enough material across the edge here. That's why when I was saying sometimes, you know, the best sort of remedy to problems like that is, you know, is just, you know, pushing the machine a little bit harder. Obviously, if you're lacking in power, or you're lacking in whatever, or you can't go any faster, you know, that's when perhaps carbide is not the best option for what you're doing, or the best option for your machine, or whatever. Or again, like I said, not the best insert. You know, some inserts need to be fed much harder than others. So it's worth doing your homework as far as inserts are concerned. Right, I think it's going to take another two moves to get down to this flange. We need to get to the thickness of this flange is 32 mil, so we need to get within 32 mil, or about 34 mil of that end there, before we can start taking it down to the diameter. So we've slowed it down again, because obviously we've got this nasty surface, and we'll I don't know how deep we are really, probably about 70 or 80 thousandths deep again. So we'll whittle away. For those of you that when we had a look around there and are thinking, oh my god, look at the state of his workshop, let me just take you out here a minute. Oh, more naked women. Look, there's me. For those of you that haven't seen me, that's what I look like. You will notice that I haven't had a shave in a while. You will notice that the calendar is actually from 2016, because because like I said earlier, I got absolutely no interest in rugby or the date. No, what I wanted to show you was if we come down into here, and you can see the state of my my bench here because I am tidied up. But this is what I want to show you, is if we can just see it there. It's dark outside, as you can see, and that is the actual time. It is actually 10:05. So this is going to be the last cut for me tonight, and then hopefully you've enjoyed it that much that you'll come back and see a great deal more of the same for part 2, which will no doubt include lots of machining, lots of tools, and possibly more naked women rugby players. Now, if that's not tempting enough for you, I'm not sure what else is. So I'm gonna leave you there, and I'm gonna finish this cut, and then I'm gonna go and have a bath and something to eat, because it's I think this is enough for any man. Next time, hopefully, we're gonna get this one finished, and then we're gonna get the next billet up, and I'll start the video when we I'm just checking where I am, and we'll start the video at getting the actual billet up into the chuck and indicating these awful surfaces and center drilling and whatnot. Okay, so thank you to all the new subscribers. It's sort of nice. One of the things I miss now that I work on my own is company. When you sort of leave somewhere where you've got 120 other people on the shop floor, it's a bit of a culture shock when you've got nobody to talk to. But so it's nice to be able to talk to all of you. So thank you very much. If you're not subscribed, please subscribe. It does help. It does sort of G me up a bit as far as getting the motivation to make these videos is concerned. Obviously it does take a lot of time to make these videos, but obviously knowing that people are watching them and that people like them, it does make it worth it. So until next time, thank you all for watching, and I'll see you soon.